stories about the moon, things that haven't been explained to this point. We've talked about them here in SkyTour LiveStream, but we have not talked about them on SkyTour Radio on KGRA. I don't know. Hey, look, it's Keith. What's going on, guys? How you doing, D? Hey, Shep. Nice to see you guys here. We're actually, I'm just poking through the skies of Cygnus tonight. Almost overhead. I don't know if cloudy, we have some haze in the air. You know what? I don't think it's bad. I think it'll be just fine for tonight. We're not going to get too far. I got to turn up my volume here. I can see that I'm low. Yeah, and Keith, last night, it was actually a lot of fun. That Space Engine, the paid version that we streamed last night, and because of the work I did with Doug Trumbull and working with the Digistar system, we actually I spent a lot of time learning how to tool around the cosmos in that mode where it's sort of a free-floating ship, and you have to sort of you drift, you aim, and then you can still see what you're looking at, and it drifts out of view unless you compensate. And that's what I learned to do when we went to we did the whole thing, you know. So I think sorry, I had the volume down. I apologize, guys. And tonight we're gonna do an actual observatory view because we have an observatory view to see. So let's just I'm just gonna take a picture here at 12,800 ISO for 20 seconds, just to get a set, because I think I've been troubleshooting a problem with the telescope, but which is why it's a little different now. You see that dome ops is on the right. I don't have dome cams going right now. That's intentional. I'm trying to eliminate some variables. It did. Shep says it felt like we were in a spaceship. It really did, because I was sort of drifting us through the cosmos, and it was really cool. This region we're looking at right now, by the way, this here is the North American Nebula, and let me get rid of me for a minute, and we can go see. You can see a little bit of the nebula here. It's sort of hazy tonight, so you really can't see too much. But you know, it's not bad. It's not bad. You know, not bad at all. So I'm thinking that it's just a real sort of a nice night for just sort of hanging out and cruising through the sky. You know what I mean? So I figure, why not? You know. So I think that and I'm glad actually that those that attended last night really liked it. Space Engine is the name of it, Keith, in case you wonder. I think I told you. And you got to get the pay version, because Space Engine is a really phenomenal system. You think you like Universe Sandbox? Wait until you try Space Engine. It's a full 3D universe. And you can go to any star you see. It has all of the galaxies. Most of them are properly labeled and identified. Really neat, you know. Right, Captain Mark Space Tour. Well, that's kind of what it was, you know. It's a good thing I didn't talk like Captain Kirk, because then I would be the center of attention and we'd all die. Isn't that what he says usually? If we don't get out of here, we're all gonna die. And Scotty, you'll be fired. I think it was really cool. Yeah, but you have the paid version, Keith? Or do you just have the free version? The free version is version 0.9.8. The paid version is 0.9.9. And it changes everything. It changes the way nebulae are viewed when you go through nebulae. And no, you can't throw Pluto at Mars, that's for sure. But you know what? We can have a lot of different types of fun. We can see the reflection nebula around the Pleiades and then go around it. And zip around it. It's really kind of cool. We can go through the Orion Nebula and hang out in the Orion Nebula and then zip around the trapezium stars in the middle and then come back out the other side. It's a lot of fun, you know. And tonight, this is where we are. We are off in Cygnus the Swan here. And I think I should endeavor to turn off that one little element here of the dome cams that shouldn't be on. Okay, so we're gonna just poke around. Right now we're up here by the North American Nebula, and we can't really see too much. Try here. Okay, the telescope's pointing there. Let's drop it down just a little bit, see if we can get something here. So when we look at the sky, we'll actually see a little bit of a change right now as we're dropping down. Okay, and there we are. I did the radio show tonight, Keith. Yeah, we talked about some lunar mysteries. We talked about some cool exoplanets, and then we had some news notes because so much is happening. Fast radio bursts, we think we know what they are now. They're a strange kind of neutron star called a magnetar that we've known about before, but the magnetars, sometimes they throw off these flares that bunch up energy ahead of them, and that bunched up energy will spiral off a very, very powerful radio burst. And the prediction is that the radio burst will trail off and drop in frequency as the burst extends. It's only a few milliseconds long, but then, yeah, it actually ends up trailing off and going down, just like we predict. So it might be magnetars that are responsible. Magnetars would tear you apart. If you think MRI machines are dangerous, holy cow. Hey, Carmen. I really think that you would find that magnetars would rip you to shreds. They'd absolutely rip you to shreds. You know. Hey, let's do a picture here, shall we? I'm just gonna do a shot here. 20 seconds at 12,800. As I said, I'm troubleshooting a problem with the telescope, so I figure, hey, why not bring you guys with me if you want to go for a ride for a little while? So yeah. Oh yeah, so Keith said, yeah, you bought it on Steam. Yeah, it was $24.99, I think. Yeah. You can also modify the one you buy on Steam as well. We're talking about Space Engine now. And the one on Steam can be modified so that you can see, for instance, oh, we got something here, look at that. So you can see, for instance, you can see, for instance, the nebulae just fine. You can also see the high resolution data. Look at this beautiful knot of nebulosity here in the North American Nebula. Where are we? I'll show you. We are right here. Let's zoom in. We're right here. You can see this little knot right here of nebulosity. And when we go back to the viewer that shows us this, we can see this little knot right there. You can see a little dark edge to it right here. So why don't we just move over and check it out, shall we? And that's what we're going to do. So let's go over and grab it. So we're going to do that now. So I'm going to move us over just a little bit. I didn't even, I barely set things up tonight because I was just trying to take care of the telescope. But I'm not using cameras on purpose. I'm troubleshooting an issue and I don't want to have the cameras in there. So I'm going to move us now a little bit eastward. Okay, because that knot of nebulous nature is right about here. So I'm going to also bring it up a little bit. Here we go. All right, so now let's do this again. Pop it over and go for it. And see what we get. So did any of you guys listen to the radio show tonight? Don't know who did, who didn't. Some may have, some might be going, what radio show? You know. Let's see where we are now. Okay. You can see some nice features right here. Let's see if we can get a little instant processing here. So a little instant processing shows us a very interesting view here. There's some water vapor in the air, some light cloud cover as well. So if it drifts through, it may hurt the view a little bit. Okay, we see some here. Let's take another one anyway. I took a beautiful photo of it here, actually, last year. It's beautiful. All right, I'll go 20 seconds at 12,800 again. Oh, Shep, yeah, great. It's from 8 to 10 p.m. Sunday nights, Eastern Time, and it's on kgraradio.com. We're actually, we look at the ratings, and I don't really talk much about the ratings, so I'm not sure I put so much trust in them. But the ratings actually show that we're like number 4 for our time slot amongst iHeartRadio and TalkStream Live, and it's really interesting to see how that works. I don't really, like I said, I don't pay too much attention to it, but overall each month we reach just about 3 million people each month, and so we're making headway. And it's really good to have an astronomy show on a paranormal radio station, because if you're the only one in town, people tend to gravitate toward you. And what it shows me is that people want to hear the science. You know what I mean? They want to hear the science. And they just think that's a wonderful thing. You know? That's a beautiful thing. They want to hear the science. So, they're going to hear the science. You can see the nebulous nature here pretty well. It doesn't look bad, and this actually might be able to monkey with this a little. Let's just zip up into changing and playing with some colors here. Let's see what we can do. Okay, I'm going to drop that. Pull that up. This is going to really stretch things. Let's just see how it looks. May not keep it, Oh, it's awesome, Chef. I'm glad. You should try it out. Tonight we talked about the lunar mysteries, like why the moon's orbit is inclined 5 degrees to the orbital plane of the Earth. There's no reason for that. And we talked about things called non-collisional interactions, which it's not a science class by any stretch, but it's actually it's a layman's view of the universe in a way that I think helps them understand. Hey, there's Harry. Hello, Harry. Nice to see you. Harry had a good time with the stream last night, actually. He was having a good time. And Harry last night actually did a really cool thing. Actually, I don't know if it was last night, Harry, or the night before. He did a head-to-head analysis of a Celestron versus a Meade, I believe. And he has some information about which one he thinks is better, if you guys are interested in getting telescopes someday. So you can contact Harry over there in the chat, and he'll tell you all about it. And Harry, I don't mind if you talk about that. That's what this is for, man. It's okay. Yeah. So yeah, we got some beautiful nebulous nature here. I'd like to take us back to our view, and actually I want to go to our stellar view. Drop out of here, and let's go down to this little guy right here. It's kind of an interesting little nebula. I want to be able to see it, hopefully. I'd like to make sure we can see it. We should actually almost be there, in fact. All right, and here we are. So, as you can see, I have the dome ops over in this corner tonight. That's only because I do not wish to have the cameras on right now. I'm troubleshooting an issue, so we'll see what happens. Okay. So where we are now is this little tiny nebula called the Blue Pillow Nebula. I believe we're looking at it right there. I can assure that by actually going into a 4K video mode, and now we can actually see for sure that that's exactly what we're looking at. I will center it up in the view here, head a little bit east. It's too bad Amanda's not here, because Amanda she likes these colors of these nebulae, especially the Blue Pillow. Well, she hasn't actually seen the Blue Pillow, and she would tonight if she was here. She was with us on the radio show, of course. I don't know if she's here tonight now, but if you're out there, Amanda, why not come along? And we got a few clouds, but I'm gonna do 20 seconds here right now at this. I gotta do a little bit of a jog with the telescope. There's a little issue that I'm trying to work through, and I've got people working on it that are gonna help. So we're actually looking at this little blue thing right here. And what is that blue thing? Well, it's the remains of a star that died. And when the star dies, that is like the size of the sun or a little bit above, in the end of its life, when it is done fusing hydrogen into helium, it will eventually swell up into a red giant. So you say, well, why is it blue? Well, because the star itself is no longer there as a red giant star. Now what we see is this blue excited gas, which is primarily oxygen, and this oxygen was made in the star and then expelled in a shell around the star as the star aged and the star bloated up as a big red giant. And then it puffed. It went big and then small. It kept oscillating, and that oscillation is the thing that determines how this material gets puffed off in a bunch of separate little shells. Like when it gets blown off, it can be like separate little shells, or it could just be one big puff. In some cases like this one, it might have been a major puff and some little shells afterwards. It depends on the structure. When we look at the structure, and when we zoom in on this, we'll see that the telescope has we need to actually do this again, but we're looking here at a kind of a fuzzy scene, and that's because we also have some clouds that we're dealing with, and that's never any fun. But you might have beat them. Let's find out, shall we? Let's do this again, and now let's do 15 seconds, because the nebula was too bright anyway. These little planetaries like this are usually pretty bright. The Cat's Eye Nebula, for instance, is really pretty. Same colors, almost a turquoisey blue. It's really something, and that's really a doubly ionized oxygen that we're seeing there. And doubly ionized oxygen is the oxygen that is ionized twice. The electrons jump off, and you have this double ionization. And what happens is, when the electrons recombine, they jump to many different energy states in the atom when they come back into the atom. All right, because ionization is when an electron leaves the atom, and when two electrons leave the atom, you get a doubly ionized atom. And then when it comes back in, they jump to all different states. But the predominant one that they jump to is the state that gives us this beautiful blue color that we see here. And that's what we're looking at here, this blue shell around the star. You can't even see the white dwarf inside, but there's a white dwarf in there. And that white dwarf is really, really hot. Okay, many tens of thousands of degrees Fahrenheit, tens of thousands Kelvin. And it is exciting the oxygen to be ionized not once but twice. And when those electrons come back in, this is what they do. They give off this characteristic blue light when they jump to the predominant energy level that they go to. And so we see it as a beautiful blue. It is beautiful, isn't it? So, that said, let's go over here to our planetarium and go down further into Cygnus the Swan. This is Cygnus the Swan we're in. There it is. Okay, the tail of the swan is Deneb, the brightest star, and the beak is Albireo, one of the most beautiful double stars in the entire night sky. All right, and it's really, really pretty. And I don't have a full sky cam on, so I don't know how cloudy it's getting out there right now. If at all, it might not be. It might be okay. But let's just move down through. Here's where our scope is right now. Right here, it's on the blue pillow. And just to show you the brightest star in Cygnus, let's go to Deneb. Okay, Deneb is an A star, and it's it's a fairly hot star. The hotter stars are B-type stars, and then O-type stars before them. O-type stars are big and short-lived. Only a few 100 million years they might last. The B-type stars are longer-lived, but not quite as long as the stars that follow. And as you move down in temperature, stars tend to last a little longer. With the stars that last the longest being the M-type stars. M-type stars are stars like Barnard's star, which is just about 6 light years away. It's a very interesting star. And these stars tend to be little percolators. They will go for not just billions of years like a sun, but trillions of years. Okay, trillions. So, and it's around those stars we find most of the planets in the galaxy, you know. And so it's really cool. Hey Dunster, how you doing? When you look at the sky, you can't see the bird like other. Well, you know what? You're not. I don't think you're not expected to see the bird. Perhaps when you look at the Cygnus the Swan. Okay, you don't. You just see stars. I mean, for the longest time, I really didn't pay any attention. Okay, now I'm using a sky filter, by the way, so you see a little bit of a blue tinge. And this blue tinge is just a product of my filter. It's not really there. The star is really pretty white. Okay. But this is Deneb, brightest star in Cygnus the Swan. We might have a little edge of the dome in here, which is why we get a little bit of a V here. Okay. So we'll just be aware of that as we move forward. We have a bear in the neighborhood now, so I'm being really careful about going outside. I have to be real careful, actually. The bear is, tend to be very, very skittish. And we had one in the neighborhood, which is kind of funny that it was near a dog. A dog was in the yard where this bear was. And the dog saw the bear. And as if in total disregard for its own safety, it ran right at the bear. It's on video. It ran right at the bear, and it jumped into the air and literally pounced on it. And the dog was probably the size of, I don't know, maybe a little, I don't even know what kind of dog it might be like a small Australian cattle dog, okay? And it jumped on the bear, which dwarfed it in size. And the bear fell down and immediately started to run away with the dog chasing it. Oh, it was the funniest thing I've seen. I was like, whoa, man, that dog is going to get killed. And a few minutes later, the dog comes trotting back, all proud of his achievement. So, yeah, the bear was actually quite surprised. We're going to a nebula that we've imaged before in SkyTour LiveStream. This is called the Crescent Nebula. It's probably going to show up in the upper left here, so I'll have to move it on down. Yeah, Shep, that's why I'm in the house. Yep. That's why I'm in the house, Shep. I don't want to be in the observatory when it's bear season, let me tell you. I just hope I don't go in there and find a bear someday. I don't leave it open. But if a bear ever makes his way in there by accident, he's going to be pretty ornery when somebody finally opens the door. But it's okay. In Arizona, there's no bears. I don't have to worry about bears. Mountain lions, yeah. Lynx, yeah. Scorpions, yeah. I was hunting scorpions last time I was in Arizona a couple months ago. And boy, that's fun. You know, they show up in a black light like you cannot believe. They're really, really bright. Really, really bright. So we're going to move over here a little bit like this. And I'm predicting that it's going to be right about here. Let's see if I'm right. So I kick it to the left to get rid of what we call backlash. And then I take off for 15 seconds at 12,800 ISO. Let's see how it goes. I'm just checking to see if there's anyone. It's like Pink Floyd. Is there anybody out there? Hey, there it is. I was wrong, but there it is. This is the Crescent Nebula right here. And the Crescent is actually a very interesting nebula because it's the remains of a star. Actually, not a remains. It's actually the result of a star that's very, very hot. And the star is actually sending this hot radiation out toward it. And when this hot radiation gets out into the interstellar medium, it collides with other material that's out there. And it forms what's called a shock front. And that's what we see. This is a shock front. I'll try 20 seconds. I'm not sure that'll work. And the shock front, by compressing material in the interstellar medium like that as it moves out, this very hot star will cause a glow because of the interaction between the radiation of the star, the increase in the temperature. It'll cause the gas, like the hydrogen gas that's in the interstellar medium, to ionize. And the ionization of this material, which you can see right here in this subtle glow, the ionization of this material is what causes the gas to glow, because when the electrons again come back into the atom, okay, this is a better instant processing of it. When the electrons come back into the atom, the hydrogen atom, they actually go to a certain energy state, and they don't all go to the same energy state. They go to many different energy states, but for some reason, at the energy levels of ionized hydrogen, the predominant state that they go to is down to what's called the N equals 2 level, and this is where the hydrogen alpha wavelength is. I think it's N equals 2. It's been a long week. I've been working on a Navy project, and I'm shipping it tomorrow, and it's all packed up finally in a crate. So I'm very pleased with that. But I've literally been working 18 hours a day, no lie. And I wrote a show on top of it for the radio, SkyTour Radio. I can't be away from that. I gotta have that. It's so much fun. We have some neat detail here. Now this is the crescent. It's called a crescent because it kind of looks like a C, but there's more detail that you can see in this nebula, and it's really a beautiful nebula when processed correctly. So I like to try and process it for all of you. I'm going to take another shot here, and I'm going to just pop up the ISO. It'll make it a little more noisy, but let's try it at 16,000. Let's see how it looks. Okay, I'm sorry. I was just reading a message. Okay, so what do we got here? Here it comes. Oh, we got a little blur there. That's no good. I don't like blurry photos. Makes me think my eyes have gone batty. I don't like it at all. Okay, so we're going to take this guy over to the east. And then run him back to the west a little bit. Take the picture. You may ask, what am I doing? Well, telescope gears over time, as they age, they may run into a little problem where there's some backlash, where the gears aren't quite touching each other. The teeth don't interlock perfectly. There's a little gap. And so it takes a couple of rotations a little bit for the... Oh, hey, look at that. Got a satellite going right through there. See that? That's what I like about SkyTour LiveStream. We get some really cool shots sometimes. And this is a neat one. This is a satellite coming through. You'll notice it was... I actually don't know when we caught it. It might have been that it was bright and then fading. So that's kind of neat. But we could take another quick photo. There's some nice detail in this photo. It's very nice. So we kind of blew it with this going on here. Let's see if we can take another photo, and I don't think it's going to be in there, frankly, because what we saw was a fast mover. So yeah, see, fast moving object. Yeah, you don't need to see me. There we go. So yeah, this is neat, and just to show you, there's more. Okay, well, it moved a little bit, but of course, we no longer have a satellite in here, so it really was moving quite fast. Yes, Dunster, it was kind of lucky. Yep. Oh, thanks, Shep, for the compliments. Very nice. I appreciate that. I'm gonna end up doing more of that stuff next week. I have to go to... I'm in Connecticut. I got to go out to Los Angeles, and I got to film a Discovery Channel show on Wednesday, and then Thursday all day I'll be doing a Travel Channel show. So I don't... in fact, I don't know what they're going to ask me on that Thursday. I only have kind of a rough idea, so we'll see. You know, they could ask me some hard questions. Yeah, don't know how to answer your hard questions. I'm sorry. Let's do another one here to get this. Wow. So let's go check out what this shows us here. Here we go. Nice photo. You can see, let me actually do some instant processing here to pull out the detail. I like being able to do the instant processing. Hey, James Dugan, how you doing? James Dugan is from Australia, and we call it the land down under, but what are we to them? Are we the land down under? You know? I mean, we probably are. Now look at that. This is beautiful. Now you can actually see the entire nebula here. The whole crescent's kind of visible here. It's really pretty. And this area of space is actually very rich with star clusters and nebulae. And this is prompting me, because the sky looks like it's cleared in this area, it's prompting me to actually think about going back to, and we're in Cygnus. I'm going to turn off the mythology here. I'm going to go back to this area of the North America Nebula and see if we can see some additional detail in the nebula. Now, Cygnus is directly overhead. It's beautiful. That's correct, James. It's all about perspective. James, I'm going to tell you a little story, and everybody, of course. I spend a lot of time talking to people about the nature of the Earth, the spherical body we're on, and I get people who believe in a flat Earth who try to say, well, look, I have this ball, it's wet, and they throw this wet ball in the air, spinning it, and saying, see, if we were on a ball, the water would just fly off. It's like, are people really that dense that they don't realize that it's almost like they completely don't believe gravity exists? So what's holding them to a flat Earth? You ask them what's holding people to a flat Earth, and they just sort of drool. They don't know what to say. There's nothing they can say, frankly, because they don't have the ability to understand, apparently, the nature of the Earth. I'm like, wow. It's really kind of sad in a way. There's a few more little things here that I can see, but I can't really tell, so I'm not gonna waste time trying to pull it out. I'm not gonna do that to you. I'm gonna head to new things, check out new things. And we're at this location of the North American Nebula. Now we're at the crescent just now, and let's go and see. There's a little nebula there. I don't know that we'll be able to see that, but oh well, we can try it, shall we? Why not? How do you know unless you try? So we go to the telescope, which is already moving, as you can tell, and it locks into position here. D. Smith, yeah. Sometimes they demonstrate that for all their intelligence that they think they have, they tend to spew the most senseless stuff sometimes. Really, really senseless stuff. Yeah. So let's see. Let's do this. All right. And we're going to okay. Now let's take a 20-second shot here. And we should, if this nebula is visible, we shall see it. I will be putting, I have a 5-inch refractor that I can put back on the telescope. But I have to get a counterweight system first before I do that. The telescope can handle the weight, it's just that it has to be balanced. And if I balance it, it'll be a lot better. All right. Oh, look at that. It actually showed up. You can see it. Look at that. Right here. Where is it, you say? Well, here it is. You can kind of see a little bit of this nebula here. That's kind of neat. I like that. You can actually see it right there. Very much so. Wow. Wow, wow, wow. That's nice. Very nice. You can see there's nebulae all around here. That's in this area, you can actually see some structure there. This is a really impressive shot. And I'm not saying I'm impressive. I'm just saying the telescope's performing admirably, considering that the night is not perfect. Actually, most intelligent ever born. Welcome. Good to hear from you. You're right. Gravity has no influence on light bending. It's not gravity that lights bend. That I think you meant to say it's not gravity that bends light. What actually happens is gravity doesn't bend light directly, but gravity bends the fabric of space, and light follows space. So if space goes down a curved section, light follows it. It's like a car on a hill, a car going over rolling hills. It follows the contour of the road. It doesn't go straight hilltop to hilltop. It follows the contour of the road. And light is like a car on the road. It has to follow the curvature of space. So yes, it will bend around corners or do whatever it has to do based on what is curving space, and that something that's curving space is gravity. So it's indirect, but in the end, gravity is. This is why we say gravity bends light. Well, gravity bends space, light follows space. It's a two-part problem. And I tell people that, and they go, "Huh?" And I explain, that if we look at the way the universe works, we look at the way light works, we look at the way that the bending of space occurs with gravitational fields, then you can actually see how it might be that we would find ourselves with a light that's curving in what seems to be empty space. And it's because if there's a gravitational field, light follows the curvature of the space that was created by this gravitational field. Okay, this guy right here, and we'll go see the bigger version of it in a minute, but this is the Little Ring Nebula. And what is the Little Ring? The Little Ring is a really cool little nebula that is, it looks just like the Ring Nebula. And we shall see it in just a moment. And I will, since we're stopped moving, let's get rid of that. Bring us a little bit here and a little bit back. And now let's take a 20-second at 16,000 shot. We actually took a picture of this once before. I don't know if any of you remember that. No, but we did. We took a picture of that before. By the way, for those watching, if some of you have not joined SkyTour LiveStream, why don't you? There's some really cool sites that we see. Oh, there's a little ring. We just have to make sure that we get it in the image properly. It was way up north of there, right? It was up north. Let's see. Yeah, we're going to bring that south a little bit. And we're going to make sure that the image is stabilized. It's not. Okay, so that's pretty good. Now we're going to kick it. All right, let's go see. Dunster, that's actually that's actually a good question. Will we ever be able to discover gravity? Actually, the nature of what gravity is. Gravity is intrinsic to mass, and that's what we're taught formally. But you know what? There are some differences, some changes that are coming down the pike regarding gravity. Gravity is not the most mysterious thing we've ever seen. Yet we can see that when we look at a gravitational field, we can predict the outcome with a gravitational field. We can't always predict the outcomes in physics, but we can predict the outcome with gravitational fields. We know how to calculate gravity. We know what the gravity between two objects is. We know how the gravitational force of an object diminishes if it loses mass. We see that with stars. This is a Little Ring Nebula, by the way. Let me just do an instant process for you. Now you can see it better. This is actually pretty interesting. I'm going to just alter this a little bit. Make this a tiny bit more, or lower this some levels here to make it just a little bit more interesting. Okay. That's a little more better, as my friend used to say when I was in college. That's a little more better. Yeah. And most intelligence says light speed in not constant. I think you meant to say light speed is not constant. And in a certain medium, light speed is constant. However, in regards to things like the fast radio bursts that we've talked about before, the light signal from these fast radio bursts can be stretched out and altered in frequency. And that alteration of the frequency is called a dispersion. And the dispersion is something that tells us about the nature of what's between these most distant galaxies. These are billions of light years away, and this fast radio burst is coming to us, and the radio burst will change its frequency, and based on how it changes its frequency, we can tell what is out in space between the galaxies. We used to think there was nothing much between galaxies. Well, now we think there's a lot more. Very interesting. This nebula right here, this is called the Little Ring Nebula, and the Little Ring Nebula is again sort of like the Ring Nebula that we know and adore. Okay, it's wonderful. But the real Ring Nebula is over here in Lyra. Okay, and let's go do a comparison directly with this one, shall we? So we're going to march right up to the Ring Nebula here. This is literally almost over our heads right now. So it's really going to be, hopefully, a very nice view, as long as we don't have a dome problem. We'll see if the dome gets in the way. Hopefully it does not. Okay, so we're pretty well locked on here. So now what I'm going to do is I'm going to pull us over and give it a shot and see what we get. And by the way, thanks for coming out, guys, all of you that have. If you haven't subscribed here to the channel, please do. SkyTour LiveStream. We have a great time. We have a lot of people. We have a most intelligent group of people. And I think that you all have good senses of humor too, as I've noticed. Yeah, and there's the ring. And you'll notice the Ring Nebula is a lot bigger and a lot brighter. And that's a really interesting coloration too. I've got the parameters way up high apparently. I want to actually bring these down. 20 seconds is way too long. Let's actually drop the ISO so we can get a sharper image. And we'll do, let's say 15 seconds at 8,000. Let's see what that brings. Let me see what's in the chat here. Now you guys are saying, let's see. Dome camera with a bear close up. Yeah, well, it'll probably be chasing me. Oh, this is really pretty. Notice this is gorgeous. Let's take a look, shall we? This image shows us something interesting about the Ring Nebula. First of all, this color is a little on the it's too shifted, and I gotta bring this back. So I'm gonna go back to all the defaults, all right, and that's more real, more better. And let's drop the gamma a little bit and change some of the other settings, make it a little bit more visible. Okay, so now if we zoom in a little bit, okay, you can see in the middle of the Ring Nebula, you can see that little tiny white dot right in the middle. That is the white dwarf that powers the Ring Nebula. And it powers the Ring Nebula because stars of a certain mass, when they die, like I said, they shed their outer layers, and the remains of the star is what's visible. You see the core of the star visible, and that core of the star is the white dwarf in there. And what happens is, when the white dwarf is visible, the radiation is coming out, and to a certain distance, it will cause the oxygen in the envelope of the star to ionize, and then the electrons recombine, and you get this classic blue colors. We've mentioned it a couple times already tonight. And then that process, because it's a white dwarf, is only a certain mass at the most. You can't have a star that's more than 1.44 solar masses become anything but less than 1.44 solar masses become anything other than a white dwarf. And so we know that means that there'll be a certain amount of radiation that it outputs to a certain range, and thus we know that most of the planetary nebulae that we see like this are going to only be a certain diameter. Now, we don't know, if we don't know the distance, we don't know how far out they've already expanded, but they typically will be about a light year or so, and it's really cool, you know. So that's the Ring Nebula with a central star, central white dwarf. Really gorgeous, and we'll bring it back now. Let's bring down the music volume a tad. All right, and let's go over and see what we can do now. We see the Ring Nebula. We saw that. That's really pretty. You know, and these little, by the way, these little red ovals you see from time to time, okay, those little red ovals are galaxies. I just saw, there's one. Okay, there's galaxies everywhere, and last night in the SkyTour LiveStream we were looking at the galaxy literally halo, where there's galaxies everywhere, as well as superclusters of galaxies. Really, we're surrounded by galaxies. We have our local group around us, and the local group is also tied to the Virgo supercluster, which is amazing. You know, it's an incredibly large cluster of many, many galaxies. And now we'll head up to this cluster we're looking at here, which we'll get to. This is a globular cluster called M50. Was it M56? Wow, can't believe I didn't remember where I was going. Oh yeah, M56. Oof. Okay, so we're here, and we're gonna just, let's see what we got here. Let's do a quick shot. 15 seconds at 8,000. I'm sorry, Dunster, did you write a question? Okay, let's get this guy. It's pretty well sun is M56. You can see the stars around. This is a globular cluster. Again, halo objects. These are objects that are in our galactic halo. They're above and below the galactic plane. And as they go through the galactic plane, they may shed stars or grab stars. So some of those stars will mix. Now, these stars in these globular clusters are called metal poor stars. And we in astronomy really love to confuse you. We think that anything that isn't hydrogen and helium is a metal. That's kind of how it works. And so I find it kind of interesting that we would look at something like this and say, well, you know, metal poor stars, you know, are stars that don't have anything other than hydrogen and helium, perhaps. And that's probably true. Probably true. So let me take another photo of this where we might actually grab a better shot. And I believe we're pretty much centered. So let's do 15 seconds here at 8,000 and see if we grab it. Hey, John Brown. Okay. And a little telescope lesson here. You'll see there's these stretched out areas here. Unfortunately, sometimes telescopes have a mind of their own. They end up blurring the image because we're going through it's a mechanical system, obviously, and sometimes the mechanical system does have failure points, and those failure points are within the drive, and sometimes they will produce a blurry photo because of something called periodic error, and it has to do with the small circuit and this stuff that these pieces of the clock drive system that are following the stars. And there's sometimes errors in the teeth of the gears that are very, very small errors that creep in, and they will cause a periodic error. And then your only hope is to just, blow past it and get through it. And so we basically just wait for the drive to get past it. The periodic error takes some time, but we'll get through it, and then we'll get a beautiful photograph of M56. Hey, AstroLive. Welcome to SkyTour LiveStream. Yeah, let's keep going here with this. I'm trying to get this to... bring it down a little bit. AstroLive, did you like, you did, right? You liked the stream last night with Space Engine, I think. Here we go. A little bit of a blur. Oh, Harry, the camera sensor, I'm doing a kind of an on-the-fly noise reduction, so you won't see the noise particularly, but I'll tell you this, I'll show you. All right, if we go back here, I'm only at 8,000 right now. Let me go up to 16,000 again. All right, and I'll take a picture at 15 seconds. We go here, this is 8,000. Right, if I zoom in, you can see noise. All right, zoom out, you don't really see noise, right? So this is kind of how that looks. But if we get back in now and view this, this is 16,000 now. You see the noise being processed out? Okay, so I'll go back to this. You see the little squares, the noise is getting processed out. You don't see it as much, but when I go into this next one now, take a look, and you'll notice right away there's lots of colors, right? And then they get processed out because I'm doing this dynamic noise reduction. Ready? Here we go. Okay, there we go. See all the squares disappearing? That's the noise reduction underway. Okay, so the native photo, it looks like this, and then it gets processed away and we get rid of that noise. I can do that separately. I've written some little routines within Photoshop that actually do this automatically for me, but you can see that we actually get some of the noise removed by this process, but all these other little areas, and again, we're looking at this error here. You see how this looks here, this noise? I can get rid of that in processing, and I tend to. And D, I don't know what I'm going to name the ship. And of course, the ship that Dee is talking about is the space engine ship that we had. It was really kind of fun last night to go zipping through the sky in the universe, you know. So, so anyway, let's see if we can find something else to view. I do know one thing I want to view. This is like one of my, I call it the fan favorite. You know, it's a real beautiful favorite. And we'll check out the Dumbbell Nebula as well. But we'll check out Albireo now. Albireo is a beautiful double star. And it's actually a star that has, two components. And those components are the orange K star and a B star, the blue B star. And when we look at these, okay, if I go from here and if I say, let's do this, this I want to do, no it's not, sorry, I want to do this. All right, now if I bring Albireo into the view, we'll see it a little more magnified. Okay, so this is the magnified view of Albireo, and you can see the colors, but and you can see how magnified the view is too. But let's actually do this. I'm going to drop the ISO down to a reasonable 1250. All right, and now you can start to see the colors looking a little bit better. And I'm going to change the exposure time and bring it down, and you'll see that this star, this is half a second right now at 1000 ISO. Let's go 1250 for 0.7 seconds, and then let's check it out. Here we go. Okay, the exposure's already done, and it's coming up. And now, when we look at Albireo, you can actually see the orange, and it's a rather unsteady night. You can see the orange K star and the blue B star. So it's pretty cool. Yeah, ship, I don't think we'll call it the Enterprise. Well, we should call it the last prize. These stars, Albireo A and B, they're separated by several thousand astronomical units. So we look at this, I think the distance is around 5,000 astronomical units. And just to get an idea, the distance to like Neptune is 30 astronomical units. So you can see that we're talking a long distance. It took us, for instance, to get to Pluto, just beyond Neptune, it took us 15 years to get there. So imagine how long it would take us to just go from Albireo A to Albireo B. It would take us a long time with our current understanding and our current capabilities. So it's a process by which we learn. But Albireo is the most beautiful little double star I've seen. I used to look at it as a little kid. I used to look at this all the time. And most of you know that I knew I was going into astronomy at age 9. I was one of those weirdos, one of those weird kids. And I can tell it's getting close to 12:30 because my lights are changing. So we're going back to condition red. Yeah, Harry, you probably did see the noise kicking in. That's the whole thing. The noise filter kicks in on the photographs, but it's a dynamic filter. It's a dynamic noise filter. So we're at 3200. I'm going to go to 4000. No, I'm not. I'm going to go to 6400 and go to, let's go to 8 seconds, and let's give this a shot. 6400, 8 seconds, Albireo. And that's cool. Now you can see, the colors tend to show up. And I could probably take these colors and play with them. So here's what we can do. We can actually increase the colors. It's called the saturation. See, you can really see the blue filter there, huh? But this is black and white, and this is in color, and these are the default values right here. We're going to leave these default values. No, I'm not going to leave those. That's a lie. And I'm going to actually just do this. Some subtle processing. There we go. Okay. And there's Albireo sitting out there. Beautiful. I mean, can you imagine being near Albireo and just like being in one of these other stars nearby? It would dominate your sky. It would actually dominate your sky. Really cool. Let's go and let's jump down now. Let's bring ourselves down to the Dumbbell Nebula. And we call it that because it's really a silly nebula. No. It's the dumbbell because it looks like a kind of an hourglass type shape. Right. And we're pulling in now. I don't have conversations that much with flat earthers. I just think that they are what I call science free. And when you're science free, you can make up the rules as you like them to be for that moment. See? So, being science free, being science free is not the way for me. Okay, I'm going to do, actually I'm going to go into the 4K video for a minute, because that way I can dynamically increase the settings. Oh, look at that. Dumbbells are right dead center. Not bad. That was a pretty good alignment. That's fantastic. Okay, so now we'll drop this down. Go back to, say, 12,800, and we'll go for 15 seconds, okay? 15 seconds, 12,800, and go. Some of the arguments you hear from the flat earthers are absolutely stunningly, flagrantly ridiculous. You know. Okay, this is the dumbbell. Nice picture of the dumbbell. Let's see if we can do a little processing here. Okay, that's too much, but I'm going to cut it back now. Dumbbell Nebula is one of these nebulae that actually has such a beautiful color set to it that you gotta, you sometimes will just stare at it. If you look at this, okay, this is a high contrast photo of it. Now I just moved the high contrast. You can see it has this additional structure on the outside with the thicker area here. Okay, and there's its central star. The beauty of the Dumbbell Nebula is in its proximity to us. It's not that far away. And if you remember the size I mentioned, that these planetary nebulae only go out to a certain distance, and that's because beyond that distance, the stars that are the typical mass that will make these can no longer ionize the gas. So there is an end diameter to a planetary nebula like this. There may be more gas out here, out beyond, but we can't see it because it's not being illuminated. So it's not like it tells us everything we need to know about these nebulae, you know. But it's actually a really pretty shot, the Dumbbell Nebula. So this is the original, and you can actually see some of the red areas here. These red areas are partially hydrogen, some neon that was made in the atmosphere of this particular star. So it's actually quite a rich spectrum, you know. In this photo, we also see some orange stars. These are little orange dwarfs, probably M-related stars. And we can see that, yeah, I get a little issue with the focusing. That's not a big deal. It is what it is. Let's go down to 10,000 for 15 seconds. It'll be a little darker, but you know what? It's going to be less noisy. Yeah, Shep, you're right. See, the water won't stick to the ball. That's correct. Water won't stick to a plastic toy ball. That is right. Yeah. Yeah. How do they think people down in James Dugan territory, right? In Australia, how do they think those people think? I mean, how do they think they survive? They're not real, you know? Oh no, they're just on the flat Earth. Oh. Okay, just at the flat Earth. Oh, and by the way, how do you explain the seasons with a flat Earth? Oh, you can't? Oh, okay. How do you explain the Earth's shadow on the atmosphere when the sun sets or rises? Oh, you can't? Oh, okay. All right. How do you explain the fact that the flat Earth, the sun approaches you and then recedes from you, but that means that in the sky, it should be smaller and get bigger as it goes over you and then get smaller as it goes away. How come the sun doesn't change size? You know, it doesn't, does it? Oh, okay. You know, and then they'll still stick to it anyway. They'll still stick to it as if they're right, even though the science clearly speaks volumes otherwise. They would rather say that everyone else is wrong and that they're right. And I think that the only reason they do it is because they just want the attention. Some of them. There are some pitiful flat earthers that actually think that what they're seeing is real. You know, what they're been told rather is real, and it's certainly a falsity. It's not true. Gosh, I just wish that people would wise up, but I don't think we're gonna get that to happen, do we? I don't think that's gonna happen, will it? These are the classic colors that we're used to seeing with the dumbbell and some of the published photos. Really pretty. You know, it's beautiful, but it's beautiful, but it belies the nature of the universe. You know, because it looks pretty, but this was born in violence. You know. I think Harry, most intelligent. You ask, does the nebula rotate? Well, actually, all these nebulae are expanding. The gases are expanding outward, and some of the gases are expanding actually at just a supersonic rates. They're not even going, at a fraction of light speed. They're going only at supersonic rates. The reason is because planetary nebulae were born of a rather non-cataclysmic nature. As the star originally that was in the middle here swelled up to a red giant, it basically would puff off its outer layers, and they would come off and just find that they're not gravitationally bound to the star anymore because of the fact that the radiation pressure from what's left of the core of the star is pushing this stuff outward. And because it's a red giant, it's very, very far from the center, and so it's not gravitationally bound, and it just keeps going. Now this that when it's going like that, when it's going like that, it's moving outward at a certain speed, and that certain speed depends on the star originally, but it's probably supersonic. So you say, well, wait a minute, this is like a light year across or so. I mean, that's a huge distance to travel. And yes, the answer is correct. It is a huge distance to travel. And we don't know whether the star is responsible for this overall shape directly, or it's the impact of this material hitting other molecules out in this interstellar medium that's causing it to change its shape. It may not be the way the star blew the material off. It might be the way the interstellar medium is reacting to the shock wave of this stuff approaching. See? And we see that a lot. When we saw the Crescent Nebula earlier, that's what we saw. We saw an example of what's called a Wolf-Rayet star blowing a lot of energy off. And where it strikes the interstellar medium, it shocks the interstellar medium, and it sends shock waves back toward the star. And these shock fronts will actually cause it'll cause a difference in the way the material looks, and it'll ionize materials differently. Just absolutely mind-boggling how the universe really works when it comes to this. So I think that it's important to consider that we're not sure how some processes work in the universe. We think that sometimes we think it's possible that in the centers of these stars, it's possible that we have a Wolf-Rayet star in the middle of many of these planetaries, just blowing material out, and that maybe what we think is a planetary nebula is really a Wolf-Rayet star expelling its outer envelope, perhaps. And they look very similar. So it's actually an interesting bit of the science, It really is. So, let's see where we are here. Okay, so we're at the dumbbell. I don't know about you, but you know what? I've never gone to view the poodle cluster. Are there dog people out there? You guys dog folks? I'm gonna go to the poodle cluster. I hope you don't mind. So, we'll check it out. I don't remember ever seeing the poodle cluster, but I bet I have. So here we go. We're moving to the poodle cluster. And supposedly, we're there. Don't tell anybody. We're at the poodle cluster. We're walking our poodle. Is it a standard poodle? Miniature poodle? Toy poodle? I don't know. Let's find out. And the way we'll do that is we're going to just take, at 10,000, I'm going to take an 8-second photo just to see what we've got. There's the poodle cluster. Right there. Interesting. I want to go here. I can see that I probably could have stood to expose this for a little bit longer. So we'll do that. Why not? Just make sure we get it right. So let's go 10 seconds at 10,000. Shep, that's funny. A female pit bull named Elmo. I like it. Elmo wants to go outside. Okay, Elmo. Yeah, looks pretty. I don't know why it's called a poodle cluster. I don't see a poodle in here. You know? Yeah. It does look like Measure 41. I'm with you, D. I don't see a poodle here. But you know what? That's okay. As you all say, you're along for the ride. It's a lot of fun. We're just going through Cygnus, having some fun tonight. Now let's see. There's going to come a point where I literally run my telescope to the edge of the dome. Let's see if we can see any of this nebulous detail tonight. Off we go into the wild dome yonder. Seeing some little artifacts here. I don't know if that's part of the dome. Well, we'll find out, because when I do a 10-second exposure, we're going to see. That always shows. I have a red light on inside the dome, so if anything at all, if any edge of the dome is in the photo that shouldn't be there, we'll see a fairly bright red area on all photos while it's in that location. So hopefully, oh, that's pretty cool. We don't have a dome here. Not bad. Okay, so look at that. That's a weird looking thing. I have not seen that before. Looks like a little tiny, almost like a very small ring of stars, doesn't it? Very interesting. I've never seen this before. I've never looked at this before. Each of those is a star all its own, which could have planets all their own. We could be looking at billions of beings right now in this one little tiny photo. We could be looking at billions of beings, for all we know. You know, these are the things I think about. Wacky person that I am. Yes, sirree. So, as we back out, let's see, how far are we? Okay, and again, we're right at the bottom of Cygnus there. So, I would be willing to bet we might see the angelfish cluster. It's going to be small. The angelfish cluster is a globular cluster, and it's actually 13,000 light years away. So it's not really that close at all, but it's one of the globular clusters, and another of the halo population. Not the game, but the population of stars that are in our halo above and below the galactic plane. So we'll see if we can see it. Okay. And by the way, I just want to thank you guys for coming out for the ride tonight. It was a lot of fun having you with me. We're going to take a look at a couple more items before I call it a night. I have to get ready to... Actually, I have to get some sleep because it's Los Angeles on, as I told you, from Tuesday through Friday next week. And then the following week, it's Norway from the 14th to the 31st. I got talks over in Norway to do. They're 6 hours ahead of me here in the East Coast. Yeah, Harry, people can support the channel. We have the super chat where people can donate if they want to. And I don't have the I need 10,000 subscribers before I can actually start offering merchandise on the stream. And that's okay. I'm doing this because I love it. But it does help to when they actually get some donations. It's good because then I can actually do upkeep and stuff on the dome. It all goes back into the dome. I don't expect to make any money here. I'm looking actually for a company and or foundation and or organization that would be willing to wow, that's beautiful, that would be willing to support me to take the observatory on the road and go around the country. I actually want to do this on a long-term basis, and I actually have a design for a portable observatory that I could take to college campuses, take to schools, take all over the country to organizations, go to dark sky sites, and operate it remotely. I mean, this, as I said, I'm in. You see me on the video. I'm in the house operating the telescope. I'm not outside. I can be thousands of miles away and do everything that you see here. And that's actually what we got to do. That's what we got to do. So, it's pretty cool, yeah, this is neat. Wow, look at that. That's a beautiful cluster right there. This is a particularly rich area. Now, what's interesting about this area is this cluster is a globular cluster. These are stars that are in our galactic arm, the Cygnus arm of the Milky Way. And this cluster is a lot further away. It's well beyond it. It's just so interesting. It's 3D. It's a 3D universe, and we don't even really even know it. But it's a really nice. It's a really nice understanding. Once you get this understanding, you'll hang on to it. You won't give up on it. And I like that a lot about this. So I'm moving back up here to Cygnus. And it says it's the Gamma Cygni nebula, but that's not Gamma Cygni. Gamma Cygni is Satyr, isn't it? Yeah, see, Satyr is Gamma Cygni. And there is a beautiful nebula right here that we know about near there. I want to try and go back up to the North American and go right here. North America, I mean. I'm going to go here again because I think I went here before, and I went there once, but I meant to go there, do something else, and I didn't do it. So let's check it out, see if we can see it. Okay. All right, we are pulling into the North American Nebula here. North America Nebula. It's not North American. It's North America. Yeah. That's interesting, James. I was actually thinking of talking to OPT as well. I had D. Smith, yeah, mobile. Oh, Harry, my God. Jesus. It's not like I didn't. Oh man, thanks, buddy. That's incredible. I'm really so pleased. Thank you so much. Holy cow. Total surprise. I don't expect this. I don't do this for money, but you know what? That makes it worth it. It makes it now. I can take that money and I can turn it right into getting some updates to the telescope that I need. Just amazing stuff. Thank you, my friend. Thank you very much. Wow. So, that's really totally above and beyond, Harry. Thank you, man. Here we can actually see part of this nebula here. This is a region of nebula that really looks great. Hey, Fantasy, how you doing? That's great, Harry. Yeah, I'm glad you love it because, you know, astronomy and the study of the universe is really kind of integral to what's going to to what we need to do. If we don't study the universe, we're never going to get off this planet. You know, we need to get out of here. You know, look at this beautiful little area right here. You know, we need to get off the planet eventually because we're going to need to move. You know, and that's something that is going to be really important when the sun begins to run out of nuclear fuel. Yes, it's billions of years away, but you know what? It may be one of these situations where we're going to have to start thinking about it as a species before long. You know? Yeah, this is you can see the nebula here. And I know that when we process this, you'll actually see more detail. And to all of you out there, if you haven't yet, I would really like to see you, try to go to the SkyTour LiveStream with Mark D'Antonio on Facebook. And the only reason I put my name in there, by the way, is because when I said SkyTour LiveStream, there were these other people that were trying to make it theirs. You know, when they saw that I was doing it, they started saying, "Oh, I'm SkyTour LiveStream." Well, they can't be SkyTour LiveStream with Mark D'Antonio now, can they? All right. So I had to throw my name in there to just get rid of them. And guess what? It did. They just went away overnight, literally. When I changed my name, they went away. And I've been climbing steadily with subscribers. You know, I'm at 3,096 or so. You know, it's not a huge number, but guess what? I was doing it like this when I had 100 people. You know, because it's not the number of people that are subscribed, it's the number of people that are actually getting something out of this and learning about astronomy. I think that people need to just be able to look up in the sky and see the stuff that's up there, learn what's up there, and it's exciting to see what's up there. Really exciting. Let me go up to, let's go to we'll go to here, NGC 6997. It's an open cluster, that's what that symbol means. Oh, an open cluster right above this area where we are. And I'm hopeful that we'll see. It might be a faint little cluster here, but that's okay. So 15 seconds at 10,000. Let's see what we get. Most intelligent. Yes, some people are cruel and should not leave and should not leave the planet. Or shall we say, some people are cruel and should leave now and be removed. I wouldn't have a problem with that, would you? Wow, look at this little cluster. Isn't this beautiful? Yeah, it's a beautiful cluster. Yes, sirree. And just for the purposes of bringing it more clearly into view, I'm going to bring it down into the view, and then we'll check it out again. Okay, and now we'll do 8,000 per 15 seconds. so it'll be a little bit less noisy. Yeah, D, our blue dot is where it's at. You know, Carl Sagan said, you know, that we are a pale blue dot. And that pale blue dot was what we obviously characterize now as our planet Earth, and what Carl Sagan characterized as the only home we've ever known. And it'll become somebody else's home someday if an alien species finds us here. And being humans as we are, we'll probably open up our planet to them and say, hey, come on in. There's room for everybody, you know, even though there's not. But we probably wouldn't want to get wiped out, by them. But the thing is, you know, and that brings up a philosophy, and it's kind of fitting to have a beautiful star cluster. This cluster has some orange stars in it, as you can see, some blue stars, some white stars. Okay, it's really an interesting cluster. And most of the stars in the cluster, by the way, are all the same type. And if you see a rich assortment, it means that there's been some mingling, and or these are in the foreground or background, and the cluster stars are at a different 3D level. But when we think about an alien species, any one of these stars, as we look at these stars actually, it's all but guaranteed that there's going to be planets around some of the stars in this image. Okay? And that being the case, we can say that there may be a chance that there's intelligent life on a planet around one of those stars, looking off of the planet and saying, who else is out there? And that who else is out there question is one that we've been asking for a long time, right? So clearly, we enjoy and we look at our universe and love to see what it's telling us. We like to try and figure out what's going on out here, and we're not really that good at it. We're just sort of, we're babies on the cosmic front, frankly. And it doesn't mean that we're babies per se. It just means that on the cosmic front, we actually are not too aware, you know. And that's okay. It'll change. Over time, I'm certain that it'll change. All right, we're going to head up to this little cluster called the Bird's Nest. It's just above the North America Nebula. And it's sitting here waiting for us to find it. So we're going to go here in a minute. So we'll go. And I'm going to drop this down. Okay, and now we'll do 15 seconds at 8,000 here and see what we get. Yeah, James, I guess they could sort of average it out. I mean, some stars have one planet, some stars have, 6, 7, 9, Well, look at this. This is really an impressive view because you get to see just how many stars there are in just one place. This is kind of like a really neat view of our in our Milky Way. It's the Bird's Nest cluster, and it's inside of the North America Nebula. Yet the North America Nebula permeates this whole thing, but we don't see it, not unless we do a deep photograph. I did some out in Arizona, and this whole area is just full of hydrogen gas that is glowing. And you just can't see it too well because I didn't expose it at the right level for checking it out. We could see it, certainly. Yeah, DPFX. Enceladus is probably one of the most interesting 310-mile diameter moons in the entire solar system. It's the only 310-mile diameter moon in the solar system. But the fact of the matter is, Enceladus shows at its south pole. It shows this, these geysers, and the geysers, have hydrogen and hydrocarbon emissions as well. And we might be looking at some oxygen, and this could be telling us that maybe what we're seeing is like in the deep ocean here on Earth, where we have these sulfide chimneys, these hydrothermal vents. We're seeing hydrothermal vents on Enceladus as well in its south pole. And the Cassini mapper at Saturn mapped the south pole of Enceladus, and you can see long striations of fissures that are bringing up thermal energy from those vents. So clearly it's warm down there, and clearly that's due to the tidal pressures on Enceladus from Saturn. And that warming effect has been going on for billions of years, and as the heat exchange occurs with space, it reaches an equilibrium inside of Enceladus. So the oceans are a certain temperature, and it may not be a temperature that's unbearable for creatures. Probably not, in fact. So we might get there might be life underneath the ice, and you might say, well, without the sunlight, I mean, how can they get energy for life? Because that's what life is, right? Life is some type of being that will acquire energy and generate its own energy, and then self-motivate, move around, so forth. And the bottom line is, when we look at life in general, life like that could be around any of these stars we see here. If we're looking at life forms, do they necessarily have to be oxygen-breathing creatures? Do they necessarily have to be carbon-based? Personally, I think, I'm a carbon bigot in a sense. I am, I guess that means I'm a carbon-biased guy. Carbon is element number 8 in the periodic table. It's also it's also one of the most beautiful elements, because it's actually the granddaddy of all elements, frankly. The carbon atom can bond with more things than any other atom in the periodic table. So hundreds of thousands of compounds can be made with carbon. And we're carbon-based. The universe provides carbon via impacts from comets and asteroids. We see carbon-based compounds being on the surface of comets all the time. Tholin compounds on on comets. We see hydrocarbons, complex hydrocarbons on Titan, ethane and methane, carbon-based compounds. So the universe provides a carbon-based template for life, is what I'm getting at. And this carbon-based template is exactly what I'm talking about. And there's another thing too. When you look at yourself in the mirror, what do you see? You see a bisymmetric being. You're the same across the midpoint of your body, left and right. That symmetry, it's called bilateral symmetry. We see other kinds of symmetry. Life has symmetry. That's the other big thing. Okay, we have carbon-based compounds that make up life, carbon-based life, and we have symmetric life. There's no life form on the planet, actually, that doesn't show symmetry. And where does that come from? It probably comes from the way DNA replicates, because DNA are two identical strands in a double helix, right? Double meaning, it splits, right? And when it splits off into one strand, which becomes what's called RNA. And then that RNA goes into a cell structure where it's zipped up with another half that duplicates it. And that's how the DNA is duplicated in our bodies. And so it's sort of setting in place sort of like a symmetry process, isn't it? So it's possible that the DNA replication is responsible for the symmetric beings that we are, and that all life on the planet is. You see, all life here is a DNA-based life. And so DNA is a template provided by the universe, for sure. It's occurring here. It probably is occurring elsewhere. Carbon-based compounds in carbon base as a template in the universe for life, and it probably occurs elsewhere as well as here. So you see, carbon-based life, DNA, the symmetry we see, whether it's bilateral symmetry with beings like us, or radial symmetry like flowers, or pentamerism, which is the five-sided symmetry that we see with starfish, which incidentally are bilaterally symmetric as larvae. When they're young, they're actually bilaterally symmetric, and they go to five-sided, which is kind of a cool development. How that was selected for evolutionary success is a mystery to me. I don't understand that. I haven't really applied myself to looking at it, though. So, we're talking about a number of things here. We've gone over a bunch of different topics. But I do like to talk about these things because I'm really certain that life in the universe is one of these things where we're not going to know all the answers, at least not right now. But we'll find some things out. Oh, you don't ask dumb questions. You know, I've heard dumb questions, and I call them dumb because they're questions from people that believe the Earth is flat, or etc. You know, remember that guy, Mad? They called him Mad Mike Hughes. Mad Mike Hughes was gonna take his steampunk rocket, powered by steam, and fly up into the sky and determine that the Earth is flat. Okay. Well, he made it up about 400 feet, and the rocket arched over and crashed. And he was using a parachute that was torn and ripped up. So it's like, I mean, really, does he want to die? Sorry, this reminded me of that for some reason. And I remember when he was making his when he was doing his attempts, I should say, he was saying, he was putting sponsors on his rocket, and I actually went into Photoshop and I painted on his rocket in Photoshop. I painted Bill and Ted's Funeral Home as a sponsor, and that went around the internet. It was hilarious. I felt kind of bad, but you know what? He trying to proclaim that the Earth is flat, and he's going to prove it. It's like, come on, man. Yeah, that's crazy. Look at this beautiful cluster. All these stars. There seems to be like this definitive edge here. And I bet if we did a deeper photo, this definitive edge right here, if we did a deeper photo, I bet you we would find that that's actually the edge of a nebula, right? And that there's dark lanes from our galaxy's spiral arms in here. I'd have to see for sure, but I bet you that the dark lanes are there. But that's beautiful. So I'm going to tell you about Mad Mike Hughes again, because there's something that he did, which I don't know, in the launch that he did was really funny. He said he was going to go up and prove the Earth was flat, so he shoots his rocket off. And of course, he has a rocket. He has a camera on board, a rocket cam, that's following his move. And it's, so you're watching the rocket cam that's pointing backwards. You can see the chute deploy. Okay, he's got a chute, and this thing comes down hard. I mean, he's in a steel can. Okay, very little padding, wearing like a motorcycle helmet. Okay, he crashes into the desert floor, and you hear nothing for a little while. And it's live. You can kind of hear. You can hear everything going on. You hear hissing from the rocket, and all of a sudden you hear, I felt bad. I was laughing so hard. I felt like I'm going to hell. And you just heard him going, because what did you expect? What did you expect? You fire yourself into the sky in a rocket. Jesus. I just couldn't believe it. You know, I just couldn't believe it. It was crazy. But hey, Mad Mike Hughes, that's why he was called Mad Mike, I would guess, right? Anyway, on that note, folks, I think I'm going to have to go to bed. It's approaching, it's 1:08 here. We've been going for nearly 2 hours. On a night like tonight, after doing the radio show, after doing 18-hour days all week, I feel as if it's probably time to actually catch up on some sleep, and I really want you to know that I appreciate you guys here. Yes, D. Yeah, that's we're going down to HE double toothpicks for laughing like this. But I just want to thank you guys for coming out. I've reached my Harry. I've reached my limit tonight. I really don't want to close up, but I have to. My body is saying time to sleep, and my mind is saying time to study more astronomy, time to look at more stars, time to go to new cool places. And as usual, what I do is I like to leave us with something that's cool that we've seen before. What could we look at? Oh, I know. Let's go take a look at this. We have seen the Veil before, the eastern and western Veil. The Veil Nebula here is a supernova remnant. And we're going to leave us with this. So we're going to go to the Veil remnant right now. You'll see the telescope indicator showing up here in a moment. And I don't see it moving yet. Where is it? It's not moving yet. So that means that, yes, correct. It means that I didn't unlock the telescope. All right, now it's unlocked. And now we can come here. And now the telescope is going to move and take us down to this location. There it comes. And so now our telescope's moving into position. We can see it there. And the stars are doing their little jog as the telescope finds the final position. All right. And right now, I'm going to guess that it's a little bit to the top and a little bit to the east. So I'm going to do this. And let's see how close I am, okay? Here we go. 15 seconds at 12,800. I might have to do 20 seconds. Thank you, Harry. That's a very, very kind statement. And once again, Harry, thank you so very much for the donation. I'm very, very humbled by that. Thank you so much, my friend. Well, look at this. There it is, right there. And I actually had this on we can actually see that the telescope did walk a little. But this view is a very pretty view, and we can actually process a little bit. And it's a little bit, the telescope did move, but don't worry, I'm going to affect the change here to make that happen, to make it go away. So let's actually do this. Increase the gamma, chop in some contrast. Okay, this is just like a little bit of, you can see some structure now better, even though it's a terrible image because the telescope had some kind of issue with movement. This happens from time to time. So what we're going to do now is bring up this, and we're going to just jog the scope a little bit. And here we go. And now we'll do it again. And check it out. Oh, Dee Dee. I was just thinking of you, Dee Dee, and you showed up. See, that's called quantum entanglement. Wow, look at that, huh? Wow, that's really pretty. That looks nice. Did I say I was going? Yeah, look at this, folks. This is a supernova remnant called the Veil. It's the eastern veil. It's the side toward the east, which is why it's called that. And you can see some really interesting structure and actually somewhat intricate structure in here. It's a very filamentary nebula, and it's so hard to close up when the sky is performing. Dee Dee, you know, I want to stick around for you, but I don't think I can, you know. Well, anyway, I am going to have to go, but you know what? I leave you with the Veil Nebula. More to come as summer approaches and recedes from us. And it's right overhead. Looks really pretty. So maybe just one more photograph. Yeah, that's me, huh? I'm Mark. More than one, just one more photograph to Antonio. That's me. Yeah, I can't put the universe away, guys. What can I say? Can't put the universe away. So, oh, that's looking beautiful. Jeez. Oh, that's looking so pretty. Yeah, I know, D. Smith. I gotta go to bed. But you know what? Look at this. Look at the screen. Look. That's really it's beautiful. Just one more photograph. Just one more. That's gonna be my tombstone. Just one more. Ay, ay, ay. Oh, man. This is. It always does this, doesn't it? It always does well. Right when I want to quit. D, you're funny. Yeah, I thought about that. I have Astro Live. I actually have a sequence generator, and I could actually set in motion a number of exposures. But I'm one of those guys that I'm used to making all the exposures sitting in the domes, and I used to use a 20-inch refractor at the college where I actually got my degree in astronomy. Then I used a 24-inch Cassegrain at the same college, and I got used to just being around the telescopes. So I actually kind of like being part of the process, even though it means I take up a lot of my own time to do it. And I think that's probably how I came to just be so, I don't know, fluid about astronomy. Just be able to, just run with it. If somebody said to me, "Go do an astronomy presentation," I don't have to prepare. I can just do it. Look at this structure. Holy cow! I even left my picture down here. I mean, if I want to get rid of it, it would look like this. Okay. But it's okay, because I'm doing just one more, just one more, just one more, just one more. The first time I get the telescope walking a little, I'll shut down. Watch, it'll be perfect now for the hours. Yep, another one. Oh well, can't get rid of this one. I'm gonna have to take another one. Just one more, folks. Just one more. Hey, and anyway, just for those that are watching, if you haven't subscribed, please think about subscribing to SkyTour LiveStream and hang out with us when we're looking at the beautiful night sky. Love to have you, and all the folks that are here are very, very friendly, very, very kind. And I think that maybe I'm reaching my limit here. Oh, Astro Live, talking about leaving gear outside. I've got thousands and thousands of dollars worth of telescope in the dome outside. Oops, that was a mistake. And so far I haven't had a problem. Knocking on plastic. You know. Look at James Dugan. A few more, please. Yeah, okay. Twist my arm. See, I wanted to go to 2 hours, and now I did. See, it's 2 hours and 3 minutes. So I think that's good. Hey, Dave Schmidt, welcome. I'm glad you're here, but unfortunately, I'm about to close up for the night. But look, Dave, this is a beautiful Veil Nebula. Isn't that beautiful? Gosh, that's beautiful. Oh, he can't hear me. Well, he'll hear it when he plays it back. I said hi to you, Dave, just so you know. I should make a little sign. Hi, Dave. David Schmidt is one of the people he's in Bangkok, and he's teaching over there. And we're going to I want to do a class for him with the observatory. And we need to figure that out, David. So when you can finally hear me, contact me, and we'll make sure that we do that for you. I'm all about the outreach. I think that the more people that see and hear about astronomy, the more they'll look up. Aha, this one is slightly blurry. Oh, guess what, folks? Okay, the telescope has gone into periodic error mode, so I am now able to close down without any concerns that the telescope's performing perfectly, because it won't be for the next few minutes. Whew. I've been saved by the inaccuracy. So here we go. Let's just see where we are. So this was the Veil Nebula in Cygnus. So we're going to close up now and leave you with the veil. But I hope you guys had a good time. I sure did. And I look forward to seeing you all again. And I'm looking forward to doing this again. And I'll probably go longer than I say I'll go. I mean, I did it before. I said I was going to go in one stream. I said I'm going to go 2 hours. 5 hours and 30 minutes later, no lie, 5 hours. It was just crazy. So really, really nuts. So that said, I am happy you guys came, and I will be talking to you guys later. Probably not right away. And who said just one more? Who said that? Who said that? Come on, who said that? I gotta go find out. Who said that? Just one more. Who said that? I saw that. Where was that? Was that you, D. Smith? Yes, it was. Just one more. Yeah, you're right, Harry. If the bear's out there, I'm not going anywhere near the observatory. But they're very skittish, you know. Well, once again, folks, thank you. This was wonderful spending time with you. And Harry, I'm humbled. Thank you so much for the donation to SkyTour LiveStream. It'll be put to good use to bring more of this to you guys. Hopefully, I will talk to you soon again, and I look forward to it. So for now, I will close down, and I will leave you with these words of wisdom. Go to bed when you're tired. Okay. Good night, all. Bye-bye.